Hello students. So we'll solve some of the problems on cofactors and permutations. So you're making use of the concept of cofactors and permutations. We have certain problems. I have solved some of the problems. So going through those problems. So the first problem is you have to, for these two matrices have been given, you have to find out the only non-zero term in the big formula. So what is the big formula? Big formula is nothing but the combinations of elements in each row, one of the element in each row, product of that. That is summation of A 1j, A2j, A3j and permutation. This is nothing but summation of your elements in each row, and they should be covering each of the columns, and multiplied with the permutation. So you have to find out the non-zero terms using only the non-zero terms that you get here. So looking at the this one matrix A, you can look at the matrix A. You have only one value. If I want to find out the determinant A, I have this only one, and depending on this only this row and column, actually what I have, leaving this row and this column, I'll have only this determinant. So one, due to this, I'll have 1 0 0, 1 0 1 and 0 1 0 as a cofactor of this one. That is, and minus, it is being multiplied with a minus value. And then for this again you have minus 1, and for minus 1 you'll have two determinants, right? So likewise you'll have, those will be the non-zero matrix. So you can find out at the some values it may be 0. If I'm taking this 1, for that you can see here, if I'm taking, if I'm writing for this matrix 1, so the cofactors are for this is, the submatrix is 1 0 0, 1 0 1 and 0 1 0. If I'm taking this one, so what will be the submatrix for that? This will be the submatrix for that. You can observe here 0 into 0. This becomes 0 and this becomes minus 1. So this terms become 0. So likewise, I'll be having many number of 0 terms. The actual total number of terms what I'll be getting here is that is 4. If I'm going for using a submatrix, I'll be getting 4 factorial. So how many terms I'll be getting? 4 into 4 3 are 12, 12 into 2, 24 terms I'll be actually getting here. Out of 24, some of the terms, determinants may also become 0. Already actual terms I'll be getting 4 raised to 4 if I am trying to expand it using a second property of a determinant. But you will have a constant sum of the determinant will be 0. So the number of terms get reduced to 4 factorial. But depending on the values in the matrix, again in this 24 some of them may contain zeros because of these zeros present in the matrix. So I'm trying to find out only the non-zero terms. So here we had seen the matrix, the big formula. So according to the big formula, what I should have? In each of the row, I should be able to select one of the columns. So look here, in this the first row, I have an option 1 in this row. So I have option of A, 2, A1, 2, the first row, and the second column I have to take, because from each of the row I'll be selecting one column element. So I don't have option in this first row, so A1, 2 has to be taken. And here you can see I have an option because 1, 2 ones are there, and in third row also I have 2 ones. You look at this fourth row, I have no options, so this is the only one, that is A, that is fourth row, the A4, 3, third column. So these are the two elements that will come into account. And so I have covered what? Second column is covered and the third column is covered. Now coming to the second row or the third row. First I will go through the second row. So in second row I have option of taking this one or this one. So look here, already third row column has been covered. So I have left out with only this option. So first option was this, and second option was this, and the third option is only this. So I have covered even the first column. So in the fourth column, what is left out? The that is third row, fourth column is left out, and this one is my choice. So This is the non-zero term. What is the combination? A, 1, 2, and next is A, 2, 1, right? And next is A, third row, A, 3, 4, and next is A, 4, 3. You can observe here first column, that is first row, second row, third row, and the fourth row. And what is your combinations? It is like second column, first column, and fourth column, and next is the third column. So in the first row, in the second row, first column, third row, fourth column, and fourth row, third element. So now what will be the values of this? Product of all this. So all are 1. So 1 into 1 into 1 into 1 will be 1. So what will be the determinant of permutation? Here I have to arrange these terms to 1, 2, 3, 4. So if if I'm exchanging this two, this one exchange, so it becomes 1 and 2. And if I exchange these two, it becomes what? 3 and 4. Your identity matrix will be getting. So number of exchanges what I have done is 2 minus 1 raised to 2. So it becomes what? Minus 1 raised to 2 becomes plus into multiplication of this, that is 1 into 1 into 1 into 1 into this 1. So total matrix determinant is equals to 1 and the non-zero terms are these, right? So for B, you can choose the B also. For B, either I can go here. If I am going in the row wise, this row wise, I am getting two terms, 1 and 2. And if I am looking at this column, I am getting this 6. Even I could have gone for this column also. So one I have shown with the row and the other I'll show with the column. So one non-zero element. Or here not necessary because I'm trying to get the columns in each of the rows, one individual column. So here I have two options, three values are non-zero and here four values are non-zero. So I'll first go with this. So this is the first option, that is fourth row. In this fourth row, this is only one option, that is first column, right? And look here in the first column, that is this is fourth column. In the first column, you have only this option. If I want to cover the first column, I have only this term. And if I want to cover the fourth row, I have only this option. So I am left out with what? This row is, column is over, this column is over, and this row I have to check. So this row is also over. I have an option with what now? First row. So look here. I have already chosen this column, and in the first row I have left out with this. But if I go to the second row, I have an option of 3 and 4. So, but here I don't have an option in the first row. In the first row, I have to choose this one, right? And in the coming to the second row, what is the option left out? Because I have to select the second column. So this second column, this 3 for this first one. So in the first row, I have the combination, that is what will be the value? A 1, 3, and second row you have second column, sorry, A22, and first third row you have first column, and fourth row you have A44. So these are your values, non-zero values, and the determinant is what? Your determinant size is first, third column, and second column, and first column, and the fourth column. So if I want to arrange what are the things I have to change, here only one exchange. It gives one. If I exchange this 1 and 3, I'll get 1, 2, 3, 4. So minus 1 raised to only one number of exchange. So what are the values here? A13 is 1 and A22 is 3 and A31 is 6 and A44 is 1. 6 3s are 18, 18 into minus 1. So minus 18 is the determinant value and that term is the non-zero term. That's in the big formula. This is using the big formula. This is the non-zero term. Understand? This itself I have explained here. You can see the first value I have got it as 1 and the second I have got it as 18. Now moving on to the second problem. So what is the question asked? So you have to expand matrix A and B in terms of cofactors of the first row. So and find the cofactors also includes minus 1 raised to I plus j and and also to find the determinants of A and B. So you have been given the matrix A. So find the determinants of A. So I have taken only A, so the matter only the determinant A I am solving. So A I have it here as this one. So what will be the I have only one here. This term is 0, 0, 0. So I'll be taking only this one term and we'll be calculating the cofactors. So you can see. So usually how do we write the cofactors? A11 into C11 and A12 into C12, A13 C13 and A14 C4. So this is 0, this is 0 and this is 0. I am left out with A12 and AC12. So here, so what will be the cofactors? So what will be the cofactors of this one? Minus 1, that is here. I have for this one, I am leaving this row and this column. What is left out? The first column 100, 101 and 010, 010. So minus 1 raised to, this is the position of this is first row and second column. So minus 1 raised to 1 plus 2, that gives me a minus value. So that will be the cofactors for C12, that is C12, and writing A11, that was minus 1. Again, I am trying to divide this into subterms, cofactors. So here I have what I have, this one, I am expanding this. This is minus 1, this one. And for this one, what I will be having? I will be having this, leaving this row and column. I am left out with 0, 1, 1, 0. And for the next matrix, that is for this one, what I'll have 0, 1, this is 0, 1 and 0, 1, leaving this column and that row. So I'll be having this. So I can find easily the determinant of 2 cross 2 matrix. So I can have this as minus 1 into what will be the determinant of this 1 into 0 minus 1. So that is minus 1 and minus 1 into 0 minus 0 minus 0. So this becomes term becomes 0, this becomes 1 minus. So the total is equals to 1. So determinant A is A12, C12 and C12 is 1, A12 is also 1, the determinant is 1. Okay. So that is your cofactors, expanding the determinant in terms of cofactors and also finding the cofactors. So second determinant B also was asked. So here this is your determinant B. So what will be the cofactors? The cofactors for first row and they had asked. So B11, C11, B12, C12, B13, C13 and B14, C14. In that you can observe that B1 and B12 are 0. So I'll be left out with only this term. So we'll try to expand the cofactor for 1. What will be the cofactor for 1? This is plus, this is minus, this will be plus because 1, this is the position is 1 comma 3. So minus 1 raised to 1 plus 3, that is 4, that becomes plus. And for this is 1 comma 4. So this becomes minus 1 raised to 1 plus 4, that becomes minus. So what will be C13? What will be C13? C1 for C13 for this you will have for this term C13. What will be C13? So for B leaving this column, this row and this column. So 0, 3, 5, 6, 7, 9, 0, 0, 1 will be the cofactor for B13, correct? So you have here the same values I have written 0, 3, 5, 6, 7, 9 and 0, 0, 1. Expand that, again expanding it. So whatever you are solved using A matrix, the same we will be having for B matrix also. This is 0. You can leave it. There is no necessity of expanding. You could have written 0. Yeah, and then also I have explained here. So leaving this column and this row, what I'll have 7901, and this is plus, this is minus, this is plus, so minus 3, and 6901. Leaving this column, I'll have this value. And for 5, leaving this column and this row, that I'll have 6700. So you can observe here, one of the row is 0, so the value determined will be 0, and here it is 6, and here it is 7. So 0 minus 3 into 6 plus 0, you are getting it as minus 18. Okay. So uh, here I have explained you regarding the cofactors. It was asked for the first row. I can even do it if it is not asked for the first row. I can do it for the first column also if you want, or I can even do it for the other way round. That is, I can even do it for the third this one. That is third column. So what you will have, you can observe here. I have done it for this one, third column. You can observe. I have it for 1. This is the outer one, and I have it for 001. Here you can see this was first for the first row, and you can observe this is for the last row. What is the last row? If I am taking this one 0, so this column and this I am leaving, so 3579. Next 0, that is for this. If I am taking for this one, what will be the matrix? Leaving, sorry, if I am taking it for second one, now what will be the matrix? Leaving this and this. So I have 0, 5 and 6, 9 here. And for the third one, that is 1, for this one, what I will be taking? For this one, leaving that column, this column, and this row I have 0, 3, 6, 7. I can expand it to the first column, first row, or the second row, or the third row. If it is asked for particularly this row, a particular row, then you can write for that. If it is not asked for a particular row, you can choose that row which has more number of zeros. So I can choose this. So instead of expanding, I could have written 0 minus 0 plus this expansion. Moving on to the next problem. So there was one more non-zero element. So that was C14, that is 2. So this also I have to take into account. So this 2, and I'm taking this 2. So I'll be having this as a cofactor, leaving that column. And again, this matrix can be subdivided into either I can take this first row, or I can see here all are zeros. So there is no necessity of dividing this into cofactors. You can write this element itself as 0. So, or if you want, you can expand and just show that this becomes equal to 0. So here I have not expanded it. I have directly written it to 0. So what will be the total determinant value? First value what I got it from the first cofactor, that is minus 18 plus 0, that I will be getting it as minus 18. The next problem that has to be explained is, let Fn be the determinant. Fn is the determinant, and the sequence 1, 1, minus 1 repeats in a tridiagonal matrix by n. So this is your sequence. You can observe, if I am writing a matrix of n cross n by n, here if I am writing 1, 1, minus 1. So 1 is somewhere here. So first second 1 and the third minus 1. So again, when I am writing this sequence, it generates. So this is, and this term becomes 0. Okay. Again, if I am shifting this diagonal, then only I am getting this 1, 1, minus 1, I am shifting it. So 1, 1, minus 1. So this is what is the size of 3 cross 3 if I am taking. You can see here this becomes 3 cross 3. This element, this minus 1 will not come into account. You will have n with 1 1. If I am going for 4 cross 4, what I will have? 1 and that is this is shifted, this is 1. So this is your 4 cross 4, this is 0, this is 0, this is 0, 0, 0, 0. This becomes 4 cross 4. And you can observe here, this is 1, this last time. If I am going for 5 cross 5, this is again 0. So this is 0, again all the 3 elements are covered, this is 0. And this becomes what? 1, 1, minus 1 has to be shifted. And one more column, 5 cross 5. So you'll have it as 0, 0, 0, 1, 1. You can see if I'm going to increase the n by n, it is ending with 1, 1 and starting with 1 minus 1. So if you remember this, this will become easy to solve that. So it is asked that by expanding in cofactors along the row 1, show that Fn is equal to Fn minus 1 plus Fn minus 2. So this is the Fibonacci sequence 1, 2, 3, 5, 8, 13 okay, for the determinants. So Fn is given here. Try to write the cofactors. So for writing the cofactors, I'll consider only non-zero elements. So this 1 and minus 1 I'll be taking 1 and minus 1. So leaving this row and this row and column, what I'll be getting? 1 minus 1, 1, 1 minus 1, right? So here also it will end like the 1, 1. I showed you how writing matrix 3 cross 2, 3 to 4 cross 4, 4 cross 4, 5, 5 cross 5. When I is increasing n, we are getting at the end, the last row was always 1, 1. So that, depending on that, I have written here 1, 1. And for size of the matrix, when we are eliminating one row and one column, the size of the matrix becomes n minus 1 and n minus 1, right? And for a second term, for the second term also, what you will be having? Second term for this, you will be leaving this column and this row. You are left out with what? 1 minus 1, 1 minus 1, and this 1, 1 remains in the previous this one. And hence the size of the matrix is again n minus 1 into n minus 1. So again taking the cofactors. So again reducing this to lower matrix, or just rearrange them first. First I'll rearrange, it is multiplied with 1 and this is multiplied with minus 1. So writing that this remains as it is and this remains, that is here you are having minus 1 and minus 1 multiplied with minus 1. This also becomes your plus 1, because the cofactor for the second term is minus into minus, this becomes plus 1. So I am leaving this matrix as it is. So you look at this matrix and the above matrix, what difference do you find here? 1 minus 1, 1, 1 minus 1, 1, 1 minus 1. You just observe here 1 minus 1, 1, 1 minus 1. And here it is 1 minus 1, 1 minus 1. It should be 1, 1 minus 1, but you are getting it as 1 minus 1, 1 minus 1, and the last 1, 1. So what I can write for that? I can write here as this is f of n minus 1. Because the size is n minus 1 after eliminating, and it is similar to f, so I will be writing it as f of n minus 1. And for the second, this one, if I arrange this to the second cofactor, observe here, this is the same. If I'm writing, adding these two, right? Using the property of the determinant, this is 0, and this term is same, this term is same, this one is, this your zeros goes on adding. So addition of these two will be nothing but f of n minus 1 itself, right? So that is like you have a, b can be expanded as what? A, 0 and plus 0b. It is similar to that. So if I am doing that, I will be getting as f of n minus 1, because this is 0, 0 adding with this same element, 0 plus 1, and this 1 and minus 1 remains same as it is. So yeah, I can write it as f of n minus 1. And taking the cofactors, what I will be writing? The next cofactor 1. Again taking the cofactor this 1. That is, I am again taking the factor of this cofactor of 1 the writing. So I'll be getting again 1 of n minus 1, 1 plus 1 minus 1 as n minus 2 into n minus into n minus 2. So again that is recursive. I can go for again. I have f of n minus 1 plus f of n minus 2. Again f of n minus 3. That it is a recursive. So if I stop here n minus 1 into n minus 1. So I have to like this. Okay. So this becomes your recursive. That is if n is equals to 5. So it is what f minus 1 that is 4 into 3. And if n is equals to 4, so then this becomes 3 into 2. So this is a like a Fibonacci series we are having. 5 we are getting it by 4 3 and 4 will be getting it by 3 2. So this is like a Fibonacci series. So the question is true, and next is just true or false. What is you have to say whether it is true or false. Look at this. The determinant of S inverse AS equals the determinant of A. Because this is the determinant, this will be automatically has to be a square matrix, and for a square matrix I can have S determinant can be written as 1 divided by determinant of S, and this determinant of S and this gets cancelled. You are left out with determinant A. So this is true. And moving on to, if determinant A equals to 0, then at least one of the cofactor must be 0. So if determinant A equals to 0, see I have taken what I have taken. I have taken an example. Then at least one cofactor must be 0. They have asked. So I have taken the example 1, 1, 1, 1, 2, 3, and 2, 3, 4. So what will be the determinant of this? Determinant of this will be automatically 0, because just check this. If I am adding row 1 with row 2, what I will be getting? 1 plus 1 2, 2 plus 1 plus 2 3, 3 1 plus 3 as 4. So the third row is linearly depending on first and second row. So automatically the determinant value will be equals to 0, because if I subtract the third row from first and second row, I'll be getting it as 0 0 0. So automatically the determinant will be 0. But check the cofactors of 1 1 and 1 in the first row. I'm taking the first row. So minus 1 raised to 1 plus 1, 1 plus 2, 1 plus 3. I'm checking the determinants, 2 3 3 4 and 1 3. This I have explained how to do. So you can observe the cofactors are not equals to 0. So the term this is false. Okay. Then it's not necessary that if its determinant is 0, cofactor has to be 0. Next is a matrix whose entries are zeros and ones has a determinant 1 0 or minus 1, because if it is equals to 1 0 1, if I am taking the entries here are in terms of ones and zeros, what will be the determinant of this? Either it should be 1 0 or minus 1. Just check to the example. What you are getting it as 2. So it is not that for the combinations. If you have a identity matrix, and then you will be getting it as 1, and if it is not more than once you are having in a row, then you will not, it's not necessary that it will be a 1 0 or 1 minus 1 or plus 1, right? If it is a determinant identity matrix, then automatically the determinant will be 1, otherwise will not be equals to 1. So it becomes false. The statement is false. So that completes your next problem. Move on to the next problem.